The sky over central Israel did not go dark that night. It burned. Streaks of fire cut across the horizon above Netanya, visible for miles. Interceptors rose to meet them. Trails split. Some vanished midair. Others continued falling. And then, nothing. No explosions in city centers. No confirmed injuries. No major impact sites. But that is exactly what makes this moment so dangerous. Because this was not a failure. It was a test of endurance, a test of pressure, and more importantly, a test of how long even the most advanced air defense system in the world can hold. And here's the question that military analysts are now asking: how many nights like this can happen before something gets through? Over the past several hours, Iran launched multiple waves of ballistic missiles toward Israel. The trajectories were visible from coastal regions, especially near Netanya and across central areas. These were not isolated launches. They came in salvos. That distinction matters. A single missile can be tracked, calculated, and intercepted. But multiple incoming threats arriving within seconds of each other begin to stretch even the most advanced systems. Most of these missiles were intercepted. Others landed in open areas. And according to available reports, there were no confirmed injuries. On the surface, that sounds like a complete defensive success. But that is only one layer of the story. Because what unfolded overnight was not just an attack. It was a demonstration of strategy. Iran has spent decades developing its missile program. This was not accidental. Unlike traditional air forces, which rely on expensive aircraft and trained pilots, ballistic missiles offer something different. They offer reach without risk. They allow a country to strike hundreds or even thousands of kilometers away without putting personnel in danger. For Iran, this became a core part of its military doctrine, especially after years of sanctions and limited access to advanced aircraft technology. Instead of competing in the skies, Iran focused on dominating long-range strike capability from the ground. And over time, that strategy evolved. Missiles became more accurate, ranges increased, payloads diversified, and most importantly, launch tactics became more sophisticated. Because modern missile warfare is not just about hitting a target. It is about overwhelming a system. To understand what happened overnight, you need to understand how these missiles are designed to operate. Many of the systems believed to be used in these attacks fall into the category of medium-range ballistic missiles. They travel at extremely high speeds during their descent phase, often reaching several times the speed of sound. That leaves defenders with a very small window to react, but speed alone is not the main threat. The real challenge comes from coordination. When multiple missiles are launched in waves, they can arrive nearly simultaneously. This creates what is known as a saturation scenario. Even if each individual missile is interceptable, the system as a whole begins to face limits. Interceptors must be launched quickly. Tracking systems must prioritize targets, and command networks must make split-second decisions. Now add another layer. Some earlier attacks in this ongoing exchange reportedly involved cluster-style payloads. These are designed to disperse smaller submunitions during descent. Instead of one target, the defense system suddenly faces many. Even if not used in every wave, the possibility forces defenders to treat each incoming object as a potential multi-threat. That increases the complexity of every engagement. Israel relies on a multi-layered air defense network. Each layer is designed for a specific type of threat. Short-range rockets are handled by systems like Iron Dome. Medium to long-range ballistic threats are addressed by systems such as Arrow. Between them, additional systems provide coverage against different altitudes and trajectories. On paper, this creates one of the most advanced defensive networks in the world, and in many cases, it works. But systems like these are not designed for a single night. They are designed for sustained operations. And sustained operations introduce a different kind of pressure. Interceptors are not unlimited. Radar systems must remain active for extended periods. Personnel must maintain high readiness, and decision fatigue becomes a factor. So when multiple waves are launched overnight, the goal may not be immediate destruction. The goal may be something else entirely: to observe response patterns, to measure reaction times, to identify gaps, and to test how the system behaves under continuous strain. Because in modern warfare, information is as valuable as impact. Every intercepted missile still provides data. Every defensive response reveals something. And every night like this builds a clearer picture of what works, and what might eventually fail. But there is one more layer that makes this situation even more complex. Despite reports that Iranian stockpiles have been reduced over time, these launches show that capability still exists. Long-range strike assets are still operational. And more importantly, they can still be deployed in coordinated waves. That changes the strategic calculation, because it means the pressure can continue, not indefinitely, but long enough to matter. And this leads to the next critical question. If the system works this well, why are analysts still concerned? Because interception does not equal immunity. And saturation does not need to succeed every time. It only needs to succeed once. The interceptions looked clean, but clean interceptions can be misleading, because what you saw in the sky was only the final seconds of a much longer and more complex battle. a battle that begins hundreds of kilometers away. The moment a missile leaves the ground, Iranian ballistic missiles follow a predictable structure, but their threat comes from how that structure compresses time. First, the boost phase. This is when the missile launches and accelerates using rocket engines. It lasts only a few minutes. Then comes the mid-course phase. The missile travels through space on a ballistic trajectory. At this point, it is outside the atmosphere, moving at extreme speed. Finally, the terminal phase. This is where everything happens at once. The warhead re-enters the atmosphere, rapidly descending toward its target. Speeds can reach several kilometers per second. That translates to multiple times the speed of sound. For defenders, this is the most dangerous moment, because by the time the object is clearly tracked and confirmed, there are only seconds left to act. Iran arsenal includes systems such as solid fuel medium-range ballistic missiles. These types of missiles are particularly important. Solid fuel allows faster launch preparation. There is no need for long fueling procedures. That means launchers can fire, relocate, and disappear quickly. This makes preemptive strikes against them far more difficult. Range is another factor. Many of these systems are capable of reaching well over 1,000 kilometers. That places all of Israel within reach from deep inside Iranian territory. And accuracy has improved. While earlier generations relied on basic inertial guidance, newer systems are believed to incorporate satellite navigation updates or terminal guidance adjustments. That does not make them perfectly precise, but it does make them far more dangerous than older designs. Now consider the payload. Not every missile carries the same type of warhead. Some are unitary, designed to deliver a single high explosive impact. Others can carry submunitions. Cluster-style payloads release multiple smaller bomblets over a wide area during descent. These are not just destructive, they are disruptive. Recent reporting suggests that cluster munitions have been used in parts of this conflict, scattering fragments and causing injuries even when direct hits are avoided. That changes the equation for defense systems, because instead of stopping one object, the system must deal with many, and not all of them are easy to track. Now shift to the defensive side. Israel's system is not a single shield, it is a layered network. At the top, long-range interceptors are designed to engage ballistic missiles outside the atmosphere. This is where systems like Arrow operate. The idea is simple. Destroy the threat before it begins its final descent. If that fails, additional layers activate. Mid-altitude systems engage targets as they re-enter. Lower layers focus on shorter range threats, including rockets and artillery. Each layer adds redundancy. But redundancy does not mean infinite capacity. Here is where the real challenge begins. Every interception requires a decision. Which missile is the highest priority? Which trajectory leads to a populated area? Which can be allowed to fall in open terrain? These decisions are made in seconds, and they are not always perfect. Because radar systems are dealing with multiple tracks at once. Objects can appear similar. Decoys or debris can complicate tracking, and incoming waves can overlap. Now add the pressure of repeated attacks. According to recent reporting, multiple missile waves have been launched during the same night, sometimes spaced hours apart. That forces the system to reset, and then engage again. Operators do not get a break. Equipment does not cool down for long. And interceptor inventories begin to matter, because every defensive missile has a cost, and every launch reduces available stock. This is where saturation becomes more than just a theory. It becomes a practical problem. If enough threats arrive at once, the system must prioritize. Some targets may not be engaged immediately, others may be engaged later than ideal, and in that small delay, outcomes can change. We have already seen examples where debris or shrapnel from intercepted missiles caused injuries and damage on the ground. Even a successful interception is not completely clean. But there is something even more important. Iran does not need every missile to hit. It only needs to keep launching. Because each wave serves multiple purposes. It applies pressure, it gathers data, and it forces the defense to reveal its behavior. Over time, patterns emerge. Response times, interceptor allocation, coverage gaps. All of this can be studied. And this is why analysts are paying close attention to the pace of attacks. Recent reports suggest that the overall number of daily launches may have decreased compared to the earliest days of the conflict. But that does not mean the threat is gone. It may mean something else, a shift from quantity to timing. Fewer missiles, better coordination, more strategic use. So when you see a night with no injuries, it is easy to assume control has been maintained. But control is not the same as certainty, because the system is being tested in real time, under real pressure, against a threat that is adapting. This leads to the deeper concern. If both sides are learning from every exchange, what happens when the next phase begins? The most dangerous part of this conflict is not what has already happened. It is what comes next. Because modern missile warfare is not decided in a single strike. It is decided over time, night after night, wave after wave, until one side reaches a limit. What you are watching unfold is a shift from shock attacks to endurance warfare. And endurance changes everything. In a short conflict, air defense systems perform at peak efficiency. Interceptors are available, operators are fully alert, command systems are sharp. But in a prolonged scenario, the variables begin to change. Fatigue sets in, supply chains become critical, and small inefficiencies start to matter. Israel's defensive network is among the most advanced in the world. But it was not built to operate without limits. Each interceptor has a cost. Each radar system requires maintenance. Each launch decision consumes resources. Over time, these factors accumulate, and that accumulation creates pressure. Not immediate failure, but gradual strain. Now consider the attacking side. Iran does not need to maintain constant high volume. It only needs to maintain consistency. Even reduced salvos can achieve strategic effects if they are timed correctly. A smaller wave launched at the right moment can be more effective than a larger one launched randomly, because timing creates uncertainty, and uncertainty forces defenders to stay on edge. This is where strategy becomes more important than firepower. Instead of overwhelming the system all at once, the goal may be to stretch it, to force continuous readiness, to create a situation where every alert could be real, and every night could bring another wave. Because constant alertness is a resource, and like any resource, it can be depleted. There's also a psychological dimension. Air defense success is often measured in percentages. 90% interception, 95% interception. But the public does not experience percentages. They experience outcomes. One missile that gets through can have a disproportionate impact, even if hundreds are stopped. That is the reality of modern conflict. Perception can shift faster than statistics. Now expand this beyond one region. Other countries are watching closely, not just for political reasons, but for technical insight. Because what is happening here is a real-world stress test of layered air defense. How systems perform under repeated ballistic missile pressure, how quickly interceptors can be replenished, how command networks adapt to saturation scenarios. These are not theoretical questions anymore. They are being answered in real time, and the implications go further. If sustained missile pressure proves effective at creating gaps, other militaries may adapt similar strategies, not necessarily copying the exact systems, but adopting the concept. Coordinated waves, mixed payloads, variable timing. Because the lesson is clear. No defense system is truly impenetrable. It can only be managed. There is also the question of escalation. So far, many of these exchanges have resulted in limited physical damage, but the capability being demonstrated is far greater. Long-range missiles, potentially heavier payloads, more complex delivery systems. If the scale increases, the consequences change rapidly, and the margin for error becomes smaller. At the same time, defensive systems will continue to evolve. Improved tracking algorithms, faster interceptors, better integration between layers. But these improvements take time, and they must keep pace with offensive innovation. Because this is not a static competition. It is a constant cycle of adaptation. So when you look back at a night with no injuries and no major impacts, it is easy to see it as a success. And in many ways, it is. Lives were protected, threats were neutralized, systems performed as designed. But beneath that success is a deeper reality. The system is being tested, continuously, relentlessly. And with every wave, both sides are learning. This is why events like this matter far beyond a single night. They reveal how modern warfare is changing, from decisive battles to sustained pressure, from overwhelming force to calculated persistence, from immediate impact to long-term strategy. And in that kind of war, the question is no longer just who can strike. It is who can keep going. Because in the end, the side that adapts faster and lasts longer is the side that shapes the outcome.